Alright, so what we have here is our finished activity diagram. Okay? Well, finished in the sense that we've replaced all of our circular nodes with our rectangular boxes, but obviously we still have to fill in a lot of the values. Okay? So as you can see from last time, we have our key here up at the top, okay, telling us what all of our different numbers in our boxes are going to represent. Okay, and if you notice, I've already gone ahead and put in all of the duration values into their proper places. Okay, since we had those values at our disposal, so I went ahead and put those in to save us some time here. Okay, so the first step, okay, so what we're trying to do here is we're trying to find the critical path. So the critical path is the path of activities that have to be completed on time in order for the entire task to be completed on time. Okay, so some of the activities have a little bit of leeway in that they can start late or finish late or whatever without really affecting the final deadline. Okay, but there are some, and that's what we call the critical path, that must be done on time, okay, or else they will delay the ending of the final project. Okay, so what we're going to do, okay, is the first thing we do is we're going to do what is called a forward pass. Okay, in the forward pass, it serves to fill in these two values here, the earliest start time and the earliest finish time. Okay, so let's start with activity A here. Okay, so early activity A, okay, is the first task, the first activity in the project here in the sequence. Okay, so nothing occurs before it. Okay, so what is the earliest time that activity A can start? Well, clearly activity A can start at 0. Okay, so I'm doing it in a different color here so we can see them. Okay. Right, so activity A is the first thing that happens. So clearly, okay, the earliest it can start is at day 0. Right? Any other value doesn't make sense, because day 1 doesn't make sense because you can always start earlier than day 1 because there's nothing preventing it from starting earlier. But you can't start at a negative value because negative values have no meaning in terms of time. Okay, so activity A, the earliest it can start is day 0. Okay, or whatever unit of time this is being measured in. Okay, so now we want to fill in our EF value, our earliest finish time. Okay, well, if the earliest that it can finish, or that it can start, I should say, is on time 0, okay, and it takes 6 units of time, okay, to complete, okay, well, what is the earliest finish time? Well, clearly, the earliest finish is at 6. Okay? Okay, so activity A, the earliest it can start is day 0. It takes 6 days to finish, so the earliest it can be finished is on day 6. Okay, so now let's look at activity B. Well, activity B requires activity A to be done before activity B can be started. Okay, so what is the earliest time that activity B can start? Okay, well, if activity A takes 6 days, the earliest activity A can be finished is 6 days, and activity B has to wait for activity A to finish, then the earliest that activity B can start is at 6 days. Okay, and so these two numbers are not equal by coincidence. Okay, so the earliest finish time of one activity becomes the earliest start time of the subsequent activity. Okay, so if the earliest start time that for B is day 6, and B takes 6 days to finish, then the earliest finish time for B is day 12. Okay, so now looking at activity C, okay, so the same idea as with B. C has A as a prerequisite, so the earliest finish time of A is 6, so the earliest start time of C is going to be 6 as well. Okay. Right, so the earliest finish time is equal to the earliest start time of its subsequent event. Okay. So the earliest start time for C is 6. The duration of activity C is 3, so the earliest finish time for C is 9. Right? 6 and 3 is 9. Okay. Okay, so let's fill in our values for our next level. Okay, so let's start at the top. Okay, so earliest finish time of B is 12, so 12 becomes the earliest start time for H. Okay, so 12 and 8 is 20. Okay, and then for E is also 12, the earliest start time, and then so 12 and 6 is 18. Okay, and then D, the earliest start time is 9 days because it comes from C. So 9 and 10 is 19. Okay, and then for activity F, earliest start time 9 days. 9 plus 4 is 13. 13 is our earliest finish date. Okay, let's go up to activity I. Okay, activity I has earliest start date of 20. Okay, and 20 and 4 is 54. Okay, now let's look at G. Okay, now here we go. Now we have a little bit of a problem. Okay, because as I had stated all along, okay, the earliest start time of an event, okay, is equal to the earliest finish time of its preceding event. But in the case of G, G has two preceding events, D and E. Okay, and they both have different earliest finish times. Okay, well, let's take a minute to think about it. Okay, so let's say that we chose the value of 18 for our earliest start time for G. Okay, that means that in theory G could start on the 18th day. Well, let's think if that makes any sense. Okay, because G requires both E and D. So G can't start until D finishes. But we've already said that the earliest that D can start is on the 19th day. Okay, so because D doesn't finish until the 19th day, so G can't start before that. So G can't start on the 18th day. Okay, so G has to start, the earliest G can start is on the 19th. Okay, so when we have more than one preceding event or preceding activity, okay, we're going to choose the greater of the earliest finish times to become our early start time. Okay, and then we go from there as usual. Okay, so 19 and 3 is 22. Okay, and then for J, we run into that exact same problem. Right, so we have two activities preceding J, G, and I. But I has the greater, 24, so we're going to use the 24 as our early start time. Okay, which means that our earliest finish becomes 28. Okay, and then that's the we've reached the end, and so just like any other activity, right, we have two events, two activities preceding the end, F and J. The J has the largest early finish time, so we're going to use 28. So we're going to put it just on top of the word end here. Okay, what that means is that 28 days is the earliest that this project can be completed. Okay? Alright, so we've found all of our earliest start and earliest finish times. Okay, that was our forward pass. So what we want to do now is we want to do what's called a backwards pass, okay, which is essentially the same thing, except we're going to start at the end and work our way to the start. Okay, so we're going to start with the 28. Okay, so I'm going to put the 28 in orange here. Okay, so we're going to put it on the bottom because our late starts and finishes are going to be on the bottom. Okay, so this 28 becomes the project length. Okay, that's how long we want the project to take. Okay, ideally, okay, because 28 is the earliest finish date, so we want it to finish on that date. Okay, because any longer it's going to cost us money. Okay, so we have this 28. Okay, so what we're doing now is we're calculating this value, this LF value, which is the latest finish date. What is the latest day that J can finish to finish on time? Well, if on time is 28 days, then the latest J can finish to be done in 28 days is on day 28. Okay? Okay? So if we want J to finish at the latest on the 28th day, then at the latest it should start on the 24th day. Right? Because J takes 4 days to finish. Okay, so just like for the forward pass, okay, we're going to move along the arrows just in the opposite direction. Okay, so here for I, okay, the latest finish is always the same as the latest start of the preceding event. Okay, so the late start of J was 24, so that means the late finish for I is also 24. Okay, and so, sorry, the late finish for I is 24. Okay, so the late start for I becomes, well, I takes 4 days to finish, so the latest I can start should be on the 20th day. Okay, well, let's look at G. Okay, so G has J as a predecessor or a subsequent event, but we're working the other direction. Okay, so the late start of J becomes the late finish of G, so 24. Okay, and G takes 3 days, so the latest start, okay, is 21 for G. Okay, and so let's continue. Right, so for H, okay, 20 goes over. 20 minus 8 is 12. Okay. E is 21. Okay. 21 minus 6 is 15. Okay. And so on and so forth.